Yeah, hello everyone. Last time we designed this little part here, the first part of our drive system, and this time we will design the second part. So I will open the part list and add a new part. It's the left part of the robot and it's version 1. Yeah, for all of you who want to know how I did the Excel sheet, just write something in the comments and then I will send you the code for the little button. It wasn't very hard to code this one, but if you want to have the code, I can send it to you. Yeah, first thing I will do, as always, is save the part. The changes in this table weren't saved last time, so there's one part missing. And I recognize this because I was building the second part of the framing group, and the problem was that it had the running number 1, and that couldn't be because I already had designed one part, and also the part with the number 1 was existent. So this is when you have some errors in your file system. Okay, this one is empty. Okay, so I can delete this one. I think this one was a test. I'm just deleting the file at the moment. So now to the part we will design today. We will start with the same thing. We will draw an equation curve. This time a different one. So this here is the first line, then we will do the offset thing again. So construction lines are treated different by the system, so it's sometimes very useful to design some lines as a construction line. So yeah, that's pretty much it. So this here is the raw shape. So now you can also see the shape because the dimensions are not here. So first we will extrude this again, and I will open the last one. It was the 0, 1. Yeah, I first have to fix some problems in the file system. There are some files double and some files are there which should not be there. So now I hope that all files are back at their places and we can go on with the planning. Yeah, as always I will drill holes into here, but first I will edit the sketch because Um, this party will be very special, but it will work. So if you are planning a part, you always have to think of you always have to think of the way how you could assemble this part. And because if you plan something and print it and then it's not possible to build this thing you were planning, then you have a big problem because you wasted material and time, and that's the reason why you always have to have a nearly whole plan of the complete robot in your head or in general of the project you're working on, so you can think of parts you will add, because also the positioning of screws is sometimes very interesting. So that doesn't really matter, because sometimes you think, oh yeah, I will connect those two parts here and here, and the problem is that you won't get the screw to this place, or if it's a part which possibly has to be repaired during the competition, you maybe will have the problem that you wouldn't get to the screw as easily as you have to. That could be a problem, because then it's your time you will lose in the competition. Yeah. I do something really wrong. Because I think so. If you're wondering why I'm sometimes very quiet or just breaking in the middle of a sentence, that's when I'm thinking about things before I tell you something. And now I did a little mistake. So what I'm doing here now is I will not expand this in one direction. I will expand this sketch into both directions because it's very symmetric, and then I can easily add the attachment point here in the middle. So this has to be a thing. So we have 10 here and 10 here. That's So Fury, we need 10 millimeters more. So it's 60 millimeters. Sorry. So now it should fit. Yep. Now it's fitting. And then you also always have to think about how is it possible to print this part, and now I'm seeing that in this case it would be not possible in a very easy way, because this here is way more than 45, so it's not way, but it's too much to print it as an overhang, and it's not possible at the moment to lay this part like in this orientation. So if the print bed goes from here, so it's under here, so this isn't possible because of the thing here. So I will have to make those two bolts as an extra part, and I will now just do this by fixing this extrusion to a cutting one, and then I have a hole here inside, so I can do the bolt as a second part and then push it in to the board when it's assembled. But that's another point. I will do the bolt as two parts that I can do a screw through it so that you can easily disassemble it again. Because if one of the drive system parts is breaking, you will have to change it very quickly, and that's not possible if you just have this bolt sitting in the board very tight. Yeah. So, and as always, I will save a little bit material that I will reach with holes again. So I will first make the sketch again. So sketch from the wrong side. So if you do not have a 3D mouse like me, this cube here is very helpful. If you are rich enough to buy yourself a good 3D mouse, you will miss it. Yeah, you will miss it, a 3D mouse if you once worked with one. And but you will not miss it if you do not have it, because the cube is then very helpful. Come on. So if you hold your cursor longer above a button, it will expand, and I'm doing this sometimes to see if there is a shortcut for this function or not, and most times there's no shortcut. But that's understandable because there are so many functions in this program. Can't just do a shortcut for everyone. And so I will add lines here. No, wait, first I will so this here is again my center point, and then I will, like in the last part, draw construction lines, type in an angle between them, so there's also a way of doing pattern repetition, but this one is not possible because this here is an equation and no circular thing. And those patterns will only work in rectangular or circular thing, or you are going to mirror the thing. So, but I will first so now I'm adding the points at the crossing lines. And the point is then at the crossing line. If both lines are black, if you set the point. And I think it wasn't always both lines black, so I better repeat this. Because if you redo scaling and some point of the program, could be that there's a problem with those points which are then not at the crossing here. They will then be somewhere in here, and this could be a problem. So it's, if you work once very clean, then you have less problems later. And I will, what's that? Yeah, I think that's better, because I will now do the holes, and I will make them, so for example, when I now change the angle of this one here to less, oh wait, you will see that the hole is moving and it now looks more symmetric. So I will give you a little more, because then it's not that close to the center hole, which is holding the whole force. Then you see all holes are moving. And now I will make this one visible. And then I could do the mirror thing, because it's so I will take one and oh, you want to have a plane, really? Okay. Want to So this is for creating a plane out of it. So now I have a plane, and then I can do the mirror thing. So I will select hole 1, mirror it at this plane here. And then you will see here the other holes. And as the last time, I will do the thing with the to deepen it in at some points. No. Yep. So I'm copying the sketch now, creating a new sketch, paste this sketch here. I will select all, make them as construction lines, and then I will do, oh wait. So sometimes it's possible that thing is not really working because of your CPU is overloaded, or other things which are other resources of your computer which are overloaded, like your RAM. But this is all okay at my computer at the moment, so it was just a thing of the program which wasn't accepting a thing I wanted to do. Okay, sometimes you do not have to understand the software. It's just trying as long as possible to find the problem behind it. It's sometimes really annoying because I was doing, I think, the exact same thing, but this time it worked and the last time it didn't. So, if some people are wondering why I'm not copying the whole part, that has the following reason: that the section here where the wheels should be attached will be different, because this wheel here will be a steered wheel, and this one here will be a static wheel. And therefore the attachment points here have to be different, and that's why I'm not mirroring the whole part. Yeah, so you could do it with mirroring, but yeah. So yeah, wait, we will destroy this mirror, and this mirror. So the best thing is if you apply your mirror very in the last things. What I will need now is a plane. And this plane. Yeah, of course it won't work. Oh yeah, I think this will work. Sometimes there are very much possibilities, so you could add a plane or an extrusion, and sometimes it's a little bit better to think a short time over how you will do this, because this will just save a lot of time in the end. Because if you see, I'm working on this part since an hour, and it's just this thing here. So I will speed up a little bit. So I will copy this and this feature. I will mirror it this plane. Can I? No, wait. So now I should be able to mirror this one here. Yeah. So it's not possible to mirror them both at the same time, but it's possible to mirror them at all. So why I'm doing this carve out here, it's just saving material again. So and if I was doing it correct, the distance between, it's 6 millimeters, and 6 millimeters is a distance which a 3D printer is easily able to bridge, so you wouldn't need any support down here. And now I will mirror the whole thing. So I just say mirror solids, and then I select the plane, and there it is. Part finished. So 2 centimeters is very thick material, but yeah, this part will has to hold a lot of stress. So there's the point stress analysis, and I will do this again. First I have, as always, to apply material to the object, and I will again test it with ABS. It's not the same thing like it's not the same thing as PLA, which we will use, but it's very close. So of course, yeah, there's also a difference between 3D printed and just molten ABS, but for first look over the stress, how the force is, I'm missing a word. Wait, Google Translate will help. Yeah, distributed in the part. Sorry for that. Sometimes I'm missing words, so I will. Oh wait, I will have to look them up. Yeah. So there will be a force of. Let's test it again with 10. And there also will be a force of 10 here. And in this thing here, it's fixed. And then let's see. How this pot looks like if you put a bit of stress on it. Okay. So these areas here are very, very good. But if you see here, there are some red zones, and if you see here, this will be a crack. So yeah, of course, the stress is completely distributed different in the part when there's a rotating point here. But to simulate this is way harder, and this is the easy way of the stress which is going onto this part here. And I think we maybe have. So in the theory I could remove even more material here, because this one here is the neutral zone, so if there's material missing in here, that wouldn't really have an effect on what's going on here, but this is not really what I want to have. So I have to mention here that I'm not calculating anything here, so In theory, it's truly possible to calculate the whole part, that you will optimize everything here, but that's not my way of planning a robot at the moment, because I do not have the knowledge to do this like professionals do. Yeah, so that's the reason why I'm just doing like the good old way. Looks good and it will do its purpose. So sometimes you have to do a little trick to the program that it will accept things. So yeah, that was what I was so that's what I was looking for. And let's see how it is like about the added material here. And you see, now we are everywhere. Okay, there we are not in the green. Thing, so we will maybe do it a bit more. Sometimes a little curve like this could have a bigger impact on the distribution of the force, but sometimes not. But you can see here now that it's distributed a bit over a wider field. So I will do this one here. Oh wait. So, and if I put this one over here, you will see, so the order here is very important. So if I will do this extrusion at the end here, the mirroring part here will not work. And yeah, so always care of the order of the steps you are planning. So if you're adding something, you have to insert it before. Okay, that was crashing. Software crash. I hope there's saved version of this part, because otherwise we will maybe have a little bit to do. Okay, of course there's no saved version of the part. But the software is still starting, so maybe there's one left. Okay, wait. Yeah, there's another thing. If you save the parts more often, yeah, it will be a very good thing. So just hitting the combination sometimes will help to reduce missing features in the part of the software crash. So normally the software is doing autosaves, but this time this didn't work out, so I will fastly re-edit this part. See you after the time lapse. So yeah, I'm back again. So in comparison, the first thing took me around 1 hour 20 minutes, and this one took me now around I think 10 minutes. And I can say to you, if you if you do a thing the second time, you will definitely be faster and it would be better and cleaner. So first I will save it again, and think I will added something here because I think there's a bit of wasting material here. We will do here one and also one here. Okay, I think we will just do the one here. So yeah, as before, we have the little stress here, and I see we have a little stress in this hole here. So this hole is reaching into the not neutral zone. So you can really see here the border of the neutral and not neutral zone. So I will place this a little bit more in this direction here. And I will also do the thing here a bit smoother. Then I will. So also a thing for you. Oh, come on. Yeah, if you are adding a hole somewhere and it's part of a group of other holes. Yeah, okay. If this is the case, just go ahead and add this directly into the whole section you already have, because then you will do not have to So you will save a few things here, so it will be more organized, because you can also do for each show here a new whole function, but then you will have like 500 items here for a little part like this, and that's way too much. So, but the position of this hole is I do not like it. So in this case, I will do a new hole, because the position is the right one. So, but the hole is too big, so I will make it just a little bit smaller, and then it should fit. Ah yeah, and you do not have to always you do not always have to close if you just wanted to do a fillet like here, and you you hit a hole, you can then just switch to fillet, and you do not have to close it and then open the next one. That's also a time-saving factor. This one is not possible. Hey, come on. Why couldn't I? Okay, out of any reason, this one is logging to be mirrored. That's very crazy. But okay, now it's working. Yeah, so I will save this again. And I hope it's not crashing while saving, because this also happened once to me. But this was a very sad moment. Yeah, it's getting better. So there's a little bit in here, but that's still green enough. I will now look at this part here. Gets out of the red zone. So that is a very nice thing, that you can simulate the stress distribution in the material before you print it, because then you can avoid cracks and save time, because maybe it took me an hour now to simulate this part here, but you see now here the red part is gone, and this is a very good sign. So now the part for me is in the most times in the green area. The biggest part of it is in the blue one. I will make this hole a little bit smaller, and then we will have a very nice part which is optimized in weight, because of course there are some options to still reduce the weight of the part, but I think I will not use them, because then it would be maybe too much, and we do not want to have a risky robot. 19 kilograms are a lot of weight. if you free print the most parts. So also very nice and helpful thing is this little lock here, because with that you can lock some lines in place, and this is sometimes very helpful. Yeah, what I maybe also have to mention is this here, the gray box here is the original shape, and this here is the shape when you apply the force on it. So the material is not breaking, so this software is also able to show you what's happening if it's breaking. So I will maybe do a little just for you to show it. Okay, this looks more or less like the thing before. And it's like 100 times as much as before. Okay, that's a good result. So yeah, I do not get it at the moment to show how the part is breaking, but that's also possible, that the deformation results in a break of the material. I will move this hole a little bit. Yeah, okay, I think it's not getting better, so we will have to deal with this little red area here, but I'm normally calculating with a higher force than the force which is applied to those parts, so save it. And now we have to design the little joint here. I will first open the bearing again, and it was 10 millimeters on the inside, and then I will add a new part. This is again a part of the framing. It's a symmetric part. It's the version 1, and its description is this one did work out really good. So back to Inventor, I will create a new part. I will directly save it, and then I will start to design it. this would be a very simple part. It will, yeah, nearly just be a 3D printed bolt. So this bolt will have at one side a little cap, so it will be oversized that it wouldn't go completely through the hole. And then there will be a loose end cap with a screw that we can screw together, so that we, in worst case, could disassemble it and could change parts. So they are designed to not break, but yeah, it could always happen. And I will do this because, yeah. So now you can see here a little shape, and can now use the resolve tool and select the shape you want to resolve, and then just say resolve it for a full circle, and the bolt is finished. So then we also give this bolt a material, and then we can save it, and then we create another part. Wrong list. Yeah, so it's again part of the framing, symmetric, version 1, and it's so here we have to added something, because I was thinking, oh, it might be a great idea if you cover the whole bearing and then you do not see anything of it, but if you screw the bolt together, you will apply pressure on it, and then maybe you will completely destroy the function of the bearing. So, but I'm overthinking another idea at the moment. So we will edit this part here again. So we'll remove some holes here. So what I was doing here, I was adding the hole for the bearing, so that we could do it in this part. If I assemble the first few parts of the drive system, you will understand what I mean. And I will save this, and then we'll do the part with the stress analysis again. So the reason for the fillet here and at the position of the bearing is that it's then easier to insert the bearing into this hole, because it would be a very tight fit, and you will need a little bit of force to press it in here, and then yeah, this helps to get the bearing in position. And what I was doing was to drill the hole after I mirrored the part, that it is recognized at a full hole and not just at as a half hole. This brings some profits for the for our stress analysis. So you sometimes always have to have a plan B if a function is not working, out of what reason ever. So I was just drawing the thing I want to have directly into the base sketch, and it's working too. So maybe it's working better than the original way I wanted to do it. So I think this is what a very nice designed part should look like. Don't know why there's the red thing, but yeah, I like it. So now this part here is finished. Yeah. Then here the thing was that the bearing is sitting inside here, so this is not the case anymore, so I can do this a bit more fancy here. For example, I will do it. So I now have to think of the possibility to print this part, and the thing I wanted to do now was something like this here, just to do more or less I wanted to do a thing like this, a bit smoother, so a bit more flat, but yeah, that would be a thing like this, and something like this, shape like this here. But the problem is that this is very hard to print. Also when I do a thing like this, so That's the reason why I would not do this. What I can do is to make it a bit nicer here at this end. I can just easily make this a bit more round. Yeah, the edges are not too sharp. So we will edit this part here in the next video. So I think if we do not split it into two parts, this video here, it's a very long one. So thank you for watching, and yeah, if you liked that video, give a thumb up. If you like our channel, just subscribe to it. That's the red button under the video. You can also hit the bell right next to it that you do not miss any of our next videos. And if you want to know about the team, just visit the video description. There's the link to our webpage and also the link to the links to our sponsors' web pages. And yeah, thank you for watching and see you next time.